Hey, hi guys. Just wait for 2 minutes. Yeah, today we are going to do a project on home loan classifier. I have taken this dataset from the Kaggle. Okay, just 2 minutes. I will start you. Okay, let's start the video. Okay, today project is on home loan classifier. I have used machine learning techniques for building a model of this classifier. Okay, let's start the video. I have importing the libraries like as NP and pandas. I think so. You already know about everything this. Okay. If you want to know more about this, please subscribe to our YouTube channel to learn about this. Okay. Input pandas as PD and now input lib py plot as plt. It is for visualization and another cbond as SNS. It is also used for visualization and I'm inputting matplot lib matplotlib inline. It is used for graphs. Just click the enter. We will done. Just wait. It's loading. It takes some time to load. Okay. Yeah, this project I have collect the data set from the Kaggle. You can go to the Kaggle and type the home loan classifier. You will get that. Okay, this perfectly execute. Now I will read the data set. I use df is equals to pd dot read csv. Whereas my data set, I have named as my data set is home underscore loan dot data set, and I will now I show the data set dot head. Yeah, you have find here this is my data set, and in this data set we have a number of columns that is find how many number columns and features also, and there is a data set nearly I think so 12 or 13 columns. In this data set, the unnecessary column is this loan id. It is an unique and we don't want that, so we can remove that data set. And gender, we also know gender means male, female, married status, dependence, education, self-employed. These are the when you're going to apply the loan and home loans like anything loan, they they can get some details about us, like this age or married a person, you are doing a job, education, like they have collected some. And the properties are urban where the home loan property. And the last one, this is my dependent variable. This is why I dependent, those these are all independent variables. Okay, let's find how many rows and columns we can find. 9 columns, whereas 13 I'm going to drop this column. So we want to drop df drop. I'm going to drop this and over the paste, copy, and axis is equals to true. We have got this. I am storing this new data into data. Okay, this is our data, and see our new input. We have 614 rows and 12 columns. In this 614 12 columns, we have 11 independent variables and one is dependent variables. Let's find, is there any null values. Data dot is nan dot sum values in this, whereas gender is 13 and married is 3 and independence is 14, 15 and self implies 13. There is a lot of null values, so we can solve these null values by using a playlist I have started newly, that is future engineering techniques. Day by day I am going to upload the videos on future engineering techniques also. By using some few little bits future engineering techniques, I am going to solve this problem. Okay, and next step is I am going to df dot use this df.info. We can find the which type of column is whereas gender is a object, married is a object, this object means it is a categorical variables, and nearly 1 2 and category variables. So we want to use this category. Now I want to data dot column and we want to do some category features. So category is equals to, I am passing all the category features in a list form of list. We have called married, gender, married, dependence, and education are up to self-employed. These are the category variable. I am copying whole up to self-employed, paste over it, and last two also it's a properties and properties. We have the loan independent variable. We don't want to take that up to properties. Yeah, we can take the property. Syntax error. Sorry, it's yeah, perfect. This is category variables, and we have number numerics. Numeric is equal to remaining the remaining columns which are present in dataset, they are numeric except loan status. Okay, remaining this is the end float up to credit history, credit card history. We can, yeah, it's absolutely entered fine. For filling the non values, I use the simple techniques that is okay. If later on in this future engineering technique and solve the problem. So now I'm using the for future in category category and that data future, where I have taken the features dot that features fill and with df, that is dot feature replace the index starts from the index 0 and comma in place is to tru true. This is filling the non values for the categorical variables, and same for we can do the numeric variables. Just I am going to copy this and paste over here, and changing this features number numeric. Let's execute. Yeah, absolutely, it's fine. Now we are going to see the is there any null values we have find. Of dot is dot sum. Yeah, we have zero. There is no there is no any null values here. After starting we have a lot of null values. There is a 13 like this. Present now we have no null values. Yeah, absolutely our data set has no null values. And for visualization part, small visualization. Okay, visualization. Now, okay, I'm going to visualize the all the category variables like pie charts and something like bot pie chart. For that, I'm using graphs df category plot dot where figure is equals to plot plt dot figure count of vary dot font some font size. It is a heading of heading like a title or heading like that. You can use font size equals to 14, and the next one step is figure the dot sub subplot figure dot just right, yeah, subtitle, not a subplot, subtitle. It's a minor mistake. Figure plot, this is a subtitle of this fig size is equals to 14 comma 6. If I got any mistakes, I will do in front of you only. Okay, now axis 1 is equals to figure dot add underscore subplot 1 comma 2 comma 1. Okay, now axis 1 dot plot x1 dot pie plot is pie chart, no, like that I'm using a pie data vary and the count of value count value counts dot labels equals to data dot data vary dot unique auto pack equals to percentage dot zero f percentage explode equals to 0.05 into data dot vary ununique. Yeah, yeah, where we have seen that in syntax. So I have used perfectly executed. I hope you have done up to here. Let's see here. I hope you have done here up to now. We are going to see the categorical features of each and everything. Like just copy this line and I am passing the categorical features. First one is gender, GEND or gender. Sorry, this is a figure site spell mistake. Your site. There is a lot of mistakes. Subtitle. Not subtitle. Spell mistake. One more spell mistake is there. The format of zero. Yeah, absolutely. Yeah, now it's fine. We have whereas male is occupy 82% and female is occupy 18%. Like that, we have going to all the categorical features. Our next categorical feature is married. Married. Yeah. Yes, 35% of married is and 65% of marriage is no. And the next, like that, we have you can do all categorical features. Okay, for all categorical features, and we are going to see. We are going to see the. It will take so much time for pair plots, so I don't want to execute the pair plots. Now we can see the df data dot data dot head. Yeah, this is our data. We have some of the zones are we have this is the we want to change the categorical features into the numerical, because why we want to change means machine learning does not take the mission does not take the categorical alphabets categories, so the missions want to take the numeric values. That's why we want to change this. So we want to find is there anything of data dot home. That's fine. Is there any unique values? How many unique? There is a unique mail and me. Let's input for the another thing. For married, for education, for finding the unique values. I have done like this. You can use the for loop also. It's for beginners, so they can understand how that. So I am using like this. It takes a lot of time to paste the copy and paste for that. And the last one is property. Yeah, let's find these unique values. Okay, we have when we compare to the gender, we have two unique values like male and female, unmarried yes or no, graduated, education graduated, not graduated, self-employed yes or no, urban public, rural, urban, semi urban. These are the unique values which are present in our data set. Okay, now we are going to do some removing all the dummy variables from this data set. So I'm using this, I'm creating a new variable, new data equals to pd dot get underscore dummies, get underscore dummies, sorry, get underscore dummies, where in our data set get underscore dummies dot data, I was where I want to get underscore dummies, use this. Okay, data dot drop where is the first now print the new data. This is our new data which I have get. All the numeric, all the values are changed. That is categorical features are changed into the numerical values. We have a lot of techniques. I will show everything techniques on my future videos. On go, you can check the playlist as a feature engineering playlist. You can get all these things. Okay, this is the simple things I have done. I'm from independent and dependent variables. I'll create this where x is equals to new data drop. I want to drop this in whereas I'm taking this I'm going to drop this x axis is equals to this is independent variables and dependent variables is new data dot this is our this is independent variables and this is dependent variable. Okay, next to form next create the train data library like sklearn. From sklearn dot model selection, import train test split. Let's execute this. Absolutely, there is no. It's never come any errors. Next, I divide the dataset into train and test, train extrain and extend there because x is divided into x and extrain and x test and y divided into y train and y test. Extrain, comma x test, y train, comma y test. Test equals to train, train, train test and split, and I'm passing the values x comma y, and test size is it's a compulsory test size is equals to 0. I'm splitting the test in test sizes that 70%. It is a most common are using when you creating a machine learning model. So we want to do it's a test size is 30% or 20 anything. Where I mean compared to train size is train data set is 70%. Okay, I hope you have all understand about this. Yeah, and the next thing is, and I'm passing the random state. State is equals to 42 or 0 as you there is a execute perfectly. Yeah, see that random state is randomly. If you want to take anything randomly, it can select randomly variable. So if you think 42, if you think like that, anything you can pass. Okay. After that, I'm building a model. Build a model or model building. For this case, I want to build a model like decision trees. By using the decision tree, I can build the model. So for that, import sklearn dot tree. Decision tree classifier. Let's execute. Is there any error? It will be execute or not? We can see. Yeah, it's perfectly executed. And model is equals to initialize this. I'm initializing this decision tree. By clicking Shift press tab, we can see all the parameters are contained in this decision tree. I'm going to take this create this parameter and one more. You can take anything, but I have taken this. Okay. And dot model dot fit the data. Fit the x1 and y1. Fit x I am fine. X1 dot y1 and run the model. Yeah, and see the now predict the values. Predict underscore predict is equals to model dot predict x test. Now we can see the output of predict. Yeah, these are the predicts, and when we compare it to the y test, it absolutely, yeah, it's a it's absolutely are equal. There is a small differences. So then our model is perfect. Now we want to go see the confusion matrix or accuracy from scalar dot matrix theorize x matrix import accuracy accuracy score confusion let's exit. Is there no confusion matrix? Not confusion. Spell mistake. Sorry for that. Perfectly. It will. I think so. It's perfectly executed. Yeah, perfectly executed. Now initialize the score is equals to accuracy score score and passing the y test underscore predict and print score. Yeah, 68%. 0.68 means 68%. If you and next thing I want to cm is equals to initialize with the confusion matrix. I am going to paste here and pass the y test underscore predict predict and cm is equals to, yeah, this is my confusion matrix. Yeah, you can go through the if you change the random state here, I will put the random state is 0. Yeah, it's executed and I will take here I will put entropy 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 execute execute execute. we have changed 72% from 68 to 72. Is a lot of difference in this. Whereas when come I will explain in statically about each and every matrix. Okay, statically playlist you can see there. In future, I will explain about that. Okay, after that, if you want to see the tree structure like tree, okay, let's import. Sorry, there is no model tree. Sorry, it's from SKLM. From SKLM, import tree. Yeah, perfectly executed. And tree dot plot the tree. We want to plot the trees, no? That one model. Let's execute. It will take some time to execute. Yeah, so. Print it executing a lot. Just wait for some time. It will be executed perfectly. For more about the data science and anything and machine learning and deep learning, just follow my YouTube channel. You can get everything in a simple way. Okay. Again, I am going to execute this. With tree method, tree legs. Just wait. It will take some time to execute. Sometime it will take some time. Yeah, perfect. Yeah, this is our tree like step structure. This is a tree like structure. If you want to get more visualize, we can see that. Okay, I hope you have understand about this small project on machine learning. Do you want more about this project? If you have any doubts or related to data science, make sure comment in comment. I will explain in my future